Welcome to video lecture number 2 for chapter 11. In this video lecture, we are going to finish up our discussion on disorders of the red blood cells. So we were talking about types of anemia in video lecture number 1. We're going to talk about 2 more types in this video. The first is called hemolytic anemia. This type of anemia is caused by a number of things, usually outside sources, like the venom of snakes, spiders, scorpions, various types of mushrooms, certain toxins that are in those mushrooms, and some drug reactions. So what these things do is they cause excessive destruction of red blood cells, which would then lead to a deficiency, which is anemia. Now, the term used for the destruction of red blood cells is hemolysis. The root hemo means blood, and the suffix lysis means destruction. So hemolysis is the destruction of red blood cells. If enough red blood cells are destroyed by one of these things, it can lead to, again, like I said, a deficiency, which would then classify it as anemia. The last type of anemia we are going to talk about is aplastic anemia. This type of anemia is brought about by an issue with a person's bone marrow not being able to produce sufficient new cells, which leads to a deficiency. And usually this is caused by exposure to radiation, exposure to chemicals like benzene, or certain drugs. So if the source of the production of cells is basically shut down or in some way hindered, that's going to lead to a deficiency, and that is aplastic anemia. We are now going to enter into some other disorders of the red blood cells, and this is one of my all-time favorite words. It's hemoglobinopathy. You can probably guess what the root hemoglobin means, but the suffix pathy means disease. So hemoglobinopathy refers to a disease of the hemoglobin in some way, shape, or form. The abnormal hemoglobin in your red blood cells causes hemolysis, which is what we just talked about, the destruction of your red blood cells. This can be caused by a blood transfusion that contains some sort of an incompatible blood type. For instance, if I were to have type A blood and I need to get a blood transfusion, and through the hustle and bustle, they give me a type B blood transfusion, and I'm type A, my body would start undergoing hemolysis due to the wrong type of blood being entered into my system, which that new blood would be seen as a foreign substance that must be destroyed. Okay, so that would lead to hemolysis. Now, some terms that we need to understand. We just talked about transfusion, so let's talk about what that means. The term transfusion means the transfer of blood or a blood component from a donor to a recipient. So that could be a full blood transfusion, or it could just be a part of the blood, like a plasma transfusion. So like when you go to college, or if you're, as an adult, if you need money, there's a place called BioLife where you can go to donate your plasma from your blood, and you get paid for it. Like I used to do it in college. And that plasma would then go to someone who needs it. That would be a transfusion when they get your plasma, because that is a blood component. And there is a certain type of blood transfusion. This is, again, one of your words, an autologous transfusion, which is where you get a transfusion from yourself. Okay, so that auto means same or self. So you are getting blood from yourself. Now, this doesn't happen all at once. Like, they're not taking blood out of you just to put it right back in. That's not how it works. It's usually a stockpile of your blood that you have in storage like in preparation for needing it, and they pull from that. So if you ever watch like FBI shows on TV, you might hear them talk about how they have or they had to have so much blood put into storage in case they should ever need it. That would be an autologous transfusion. A similar but still very much different word is an infusion, which is an introduction via an IV of some substance other than blood. So this could be like a saline solution. When you just go into the ER, they usually just give you a saline solution through an IV, or it's literally any other substance that isn't blood is classified as an infusion. Now going back to the disorders and thinking back to video lecture number 1, we talked briefly about polycythemia in relation to hematocrits. Polycythemia vera is the overproduction of red blood cells like you see in the picture on the slide. The cause of polycythemia is unknown. We don't know what causes a body to produce more red blood cells than needed, and it can be diagnosed very easily with that simple blood test, comparing it to what the level of red blood cells should be. If we look at the word polycythemia, the prefix poly means many, the root cyth means cell, and the suffix emia means blood. So polycythemia is many blood cells or the overproduction of red blood cells. Okay, and this disorder can be deadly if it isn't diagnosed or treated in a timely manner, but the symptoms are pretty generic. So if you are experiencing weakness, fatigue, joint pain, and headache, to name a few, those could be a sign that you have polycythemia. Again, it's not known why you would develop polycythemia, but again, it is an issue if you don't get it diagnosed and treated in a timely manner. Some terms you might have heard before: antigen and antibody. They are somewhat related to each other. An antigen is a protein on a cell that triggers the production of an antibody. Okay, so this could be any virus that enters your body. This is how we develop our immunity to certain diseases. When we get the flu, right? That's a viral infection. The antigens on the flu virus are going to cause our body to produce antibodies that would fight off the flu should it come back. The issue with the flu is going to continue to mutate, which is changing those antigens. So the antibodies we had produced prior are not going to fight off the mutated version, but that's how immunity works. We also have antigens on our red blood cells that produce antibodies for the other types of red blood cells, which is why we can't get an incompatible blood transfusion. An antibody is something that destroys or inactivates a specific antigen when that antigen enters the body. So for instance, let's say again that I have type A blood. That means that I have the type A antigen sticking off of my red blood cells, which is represented by light blue circles on the diagram on this slide, in that upper left-hand box where it says antigen A. So let's say I have type A blood. That means my red blood cells have antigen A on them. So my body then, while I was developing in the womb, produced anti-B antibodies that are made to attack antigen B that is located on type B blood cells and type AB blood cells. So those are represented by the purple triangles on the diagram. So if I, with type A blood, were given a blood transfusion containing type B blood, my anti-B antibodies would attach to the B antigens on the new blood that I was given, causing the new blood cells to clump up and be destroyed by my body. So if I have type A blood, I cannot get blood from type B or type AB, but I can get it from type A or from type O. Okay? The fancy term for antibody is immunoglobulins, which is abbreviated capital I, lowercase g. So again, that's not a typo. Another component of blood cells is the Rhesus factor, which is abbreviated capital R, lowercase h. Now this codes for another type of antigen on your red blood cells. So if you are Rh positive, your red blood cells contain antigen D on their surface, which are represented with the blue squares in the diagram, along with whatever other antigens come along with your blood type. Okay, and your body will not ever produce the your body will never produce the anti-D antibodies. If you are Rh negative, that means that your red blood cells do not contain antigen D, so that's why there's no blue squares on the negative red blood cell in the diagram, okay? And your body will produce anti-D antibodies if you are ever exposed to Rh positive blood, like through a blood transfusion. Okay, if you are Rh negative, you are not born with those antibodies. You only develop them if you are exposed to Rh positive blood in some way. Okay, now this really comes into play when women begin to have children. So let's say that we have a woman who is Rh negative. Okay. She becomes pregnant by a man who is Rh positive. Now, if you know just basic genetics, Punnett squares, there's a chance that their baby could be either Rh positive or Rh negative, depending on the alleles that it's given by mom and dad. Okay? If the baby happens to be Rh positive, and remember the mom is Rh negative, okay, the placenta prevents the mixing of the blood, but at birth, and even if the mother has a miscarriage, the fetal cells can enter into the mom's bloodstream. And since the mother was Rh negative, and she has now been exposed to Rh positive blood, her immune system is going to produce the anti-D antibodies. Okay, so she didn't have them before, but due to the exposure from the Rh positive baby, she now has the antibodies, the anti-D antibodies. So now if the mom were to become pregnant again with another Rh positive baby, okay, the antibodies can cross the placenta. Okay, the blood cells can't, the antibodies can. The antibodies would cross the placenta and cause agglutination, which is the sticking together of red blood cells, and it would cause hemolysis of the baby's red blood cells, which obviously is a huge issue. This is going to cause what we call HDN, or hemolytic disease of the newborn, but it can be prevented. So if the mom knows that she runs a chance of having this happen, she can be given something called Rh immune globulin. Oh my gosh, there we go. Either while she's pregnant or after the birth of her first child to prevent this from happening. Okay, and that is going to be it for video lecture number 2.